We have already seen the different manufacturing processes for the pipe body. Now we are going to see the main finishing operations to be carried out on the pipe body to get the final OCTG product. The finishing lines perform the final operation of the tube coming directly from the rolling or from the heat treatment process, if it was necessary. There are several finishing operations, and the use of each of them depends on the type of the tube and customer requirements. Both seamless and welded pipe have a similar finishing process. In this unit, we will describe the main steps in detail. Let's start talking about cutting, facing, and beveling. In this stage, the tube is cut to the final length, faced, and beveled before threading. The purpose of the bevel is to help the beginning of the threading operation. Other process is the upsetting. The main objective of upsetting is to increase the wall thickness at the end of the tube to allow further threading operations. Upsetting consists of increasing the wall thickness of the tube ends by a forging action with two half dies and a punching mandrel into the tube. After upsetting, the tube is sent for heat treatment. Threading is the following step, and if the tube will be threaded with API connections, automatic machines will keep the tube in a fixed position while the headstock rotates. After threading, the threads are visually inspected and controlled according to an inspection plan. If the tube will be threaded with premium connections, computer numerical control lathes, known as CNC lathes, are utilized, and the tube rotates while the turrets with the tool holders machine the ends. After threading, coupling makeup is performed to obtain the final tube. The makeup operation is performed by controlling the makeup parameters that are typically the minimum and maximum shoulder torque, the minimum and final makeup torque, and the coupling position when it applies. Drifting is another finishing process performed to check the tube's internal diameter after the coupling assembly. A mandrel should pass throughout the full length of the tube without suffering any obstruction. To guarantee the mechanical integrity of the pipe, a hydrostatic testing is performed. This process consists of filling the tube with a fluid, which is usually a water and oil emulsion. The fluid pressure is increased until reaching the specified test value, and this pressure must be held for a certain time. After hydrostatic testing, the tube is passed through the measuring, weighing, and stenciling stations, known as MWS. These operations are carried out for tracking reasons and to fully comply with the API standard and with the purchase order requirements. Following this process, the tube is taken to the lacquering, varnishing, oiling machine. When specified either by the standards or by the customer, the lacquer, varnish, or oil application is performed to protect the tube and prevent corrosion during storage or transportation. Another finishing process is the bundling. It is performed typical for tube sizes up to 4.5 inches. It consists of strapping a number of pipes together to form a package. When finished, the pipe is sent to the storage yard for the later dispatch to the client. During the finishing process, there are special operations which include swaging, that is a cold forming operation which modifies the shape of the tube ends in order to have an appropriate machining allowance for the proprietary connection to be machined. Phosphatizing, that consists of coating the coupling surface with a layer of non-metallic and fine crystalline phosphate to prevent the threads from galling. Dopeless coating, that is a proprietary system developed by Tenaris to eliminate the use of dope or thread compound. Doppler solution is a dry film coating that simultaneously provides lubrication and long-term corrosion resistance. Several non-destructive tests, NDT, must be performed. These are inspection methods used to search for the presence of defects on the tube. In Tenaris, 100% of the production is subject to NDT, combining the different alternatives such as electromagnetic testing, ultrasonic testing, and visual inspection. Electromagnetic testing is used for internal and external surface inspection, as well as for testing steel grades. The tube is transverse or longitudinally magnetized according to the type of defects to be detected. Defects generate dispersion in the magnetic flow, which induced electric signals in the equipment sensors, and it travels through the defect area. If the tube shows defects, it is sent to a prove-up table. Then it undergoes a dry magnetic particle inspection. Ultrasonic testing uses high-frequency sound waves to conduct examinations and make measurements. Ultrasonic inspection can be used for flow detections or evaluation, dimensional measurements, material characterization, and more. In case of defect detection, the tube is sent to a prove-up table. Visual inspection doesn't use any precision instrument, and it is performed to detect surface defects. Any defect found by any means is removed by grinding, and then the remaining wall thickness is controlled to ensure that it is still within the specified wall thickness tolerance. If the defects can be removed, then the tube is re-inspected. Otherwise, it is rejected.